A very good afternoon to you all grade 12 learners. Welcome to today's mathematical literacy lesson. My name is, as usual, Mampani Kekana. And remember that the lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. So now, boys and girls, as you can see today, we are also going to look at another interesting and a very simple topic or section of data handling, which is a representation of data, of which in simple terms we are going to look at the questions that are based on graphs that we do in data handling. And then, boys and girls, as always, there's always a way of scoring marks in the subject. And then in this section of data handling, which is paper 1, you can actually score a lot of marks, since most of the questions that are based on the graphs are actually very, very, very easy questions. So as I indicated, we are now going to look at the data handling, and this data handling, it's a representation of data. Now, as I have just mentioned, at the end of this lesson, you should be able to revise. So remember, I understand at school level, most of you are done with ATP coverage. You either wrapping up, or you are just about to do revision, or you are busy with revision and so on. So we are actually taking you back to the beginning of the year, where we revise all the topics that we have done, because we are now preparing ourselves for the prelim examination. Then in simple terms, in this, you must be able to revise the graphs, namely the box and whisker plot. Remember, box and whisker plot, the pie chart, the line graph, the bar graph, histogram, scatter plot, and all those other types of graphs that you have learned. But in today's lesson, we are going to focus on representing, interpreting, and analyzing the data. So basically, it's just an interpretation of the information on the given graph. Of course, terminologies, boys and girls, very, very important that all the terminologies that you are working with, you should be able to define them. The examiner might ask you to define the terminologies. Like, for instance, you cannot be working with bar graph, but you can explain what a bar graph is. You can explain what a bar graph is in few words, not necessarily a paragraph or word, just 5 or 6 words that will be enough for the examiner. Now, what do we mean by a bar graph? It's a graph that is represented in the form of bars representing discrete data. Graph represented in the form of bars representing discrete data. Now, you remember, discrete data is the type of data that can be counted. And then we've got a histogram, graph represented in the form of bars representing continuous data. So you can see the bar graph and the histogram. The only difference is the bar graph is representing discrete data, and the histogram is representing the continuous data. And then, of course, a pie chart. I'm sure most of you have an idea of how a pie chart looks like, but now the definition is very, very important. It is a circular graphical representation of relative portions of data in the form of slices. It is a circular graphical representation. Those are the 3 most important words in the definition of the pie chart. Circular graphical representation. And then, of course, we've got a line graph. It is a type of graph that displays data in the form of coordinates. Coordinates, remember, it's a point where you're plotting, joined by line segments. It is a type of graph that displays data in the form of coordinates joined by line segments. And of course, box and whisker, however way you can define it, but the most suitable definition is it is a graphical representation of minimum value, quartile 1, quartile 2, quartile 3, and maximum. Remember, you must have the picture of this box and whisker. The box and whisker indicates the maximum, indicates the minimum, quartile 1, median, quartile 3, and maximum. So in other words, it's a minimum, quartile 1, quartile 2, which is the median, quartile 3, and then the maximum value. And then of course, as scatter plot, it is a type of graph that shows the relationship between the two sets of data. It is the relationship, or it is the type of graph that shows the relationship between two sets of data. So boys and girls, the definitions are very, very important. Every graph that we are working with, you must be able to define it, okay? Please go back to your notes, okay? We are not saying change the definition or the definitions that your educator gave you, but the definitions obviously will be more or less the same as the ones that I'm explaining now. So it's just up to you to have an idea of what if they ask me what scatter plot is, what if they ask what box and whisker is, what if they ask what line graph is. You should be able to define. I know that most of you can picture, you have a picture of those graphs, but explaining them might be difficult, but just have an idea and be able to explain using about 4 to 5 or 6 words. Now going back to the bar graphs, just the pictures to give an idea. We've got the bar graphs. Then as we indicated that it is a graph representing discrete data. It is a graph that is representing discrete data. Okay, then there we've got types of bar graph, because in some cases the examiner might ask you to name a bar graph or the type of bar graph. Now with a bar graph, of course, we've got the most common one, which is a single bar graph. Even if you just say bar graph, that will be acceptable, but this is actually a single bar graph. And then we've got, of course, we've got bars that are combined. Okay, the bars that are combined but with different meaning, okay, or representing different information. Like in this case, you can see here we've got a blue one and we've got an orange one. There we've got a blue one, we've got an orange one. So this one, because we've got two of them combined, we can say it's a double bar graph. Double bar graph. If you've got 3 of them, then you can say triple bar graph. If you've got 4 of them combined, in this case, then you can say it's a multiple bar graph. So if it's 2 of them, double bar graph. If it's 3 of them, triple bar graph. If it's more than 3, you can say multi-bar graph, okay? Or multiple bar graph, sorry. It must be multiple bar graph, okay? And then, of course, we've got this one, but you can see that the bars are now in a different orientation, but it is still a bar graph, but we just say it's a horizontal bar graph. It's a specific type of a bar graph in this case, which is a horizontal bar graph. And then again, we've got a type of bar graph where the different bars are stacked on each other. Like in this case, you can see I've got bars with different colors. Okay, so this one are stacked on top of each other, So this one we say is a stacked bar graph. So just have an idea. I'm sure your educator has indicated this to you, that in a case of a bar graph, we actually have different types of bar graphs. And then, of course, we've got histogram. Now, boys and girls, it's very important to differentiate the two, because most of the learners are still getting confused in the examination. When they ask them to draw a bar graph, some of them are still drawing histogram. When they say draw histogram, and then some of you are still drawing a bar graph. So you must know that in case of a bar graph, in case of histogram, you can see that we don't have spaces in between. There's no spaces in between. So this one is histogram. So histogram, it is a graphical representation of continuous data using bars, but in this case, the bars are combined. Okay, and then we spoke about line graph. Okay, this is the picture of a line graph. Still with the explanation, it is a type of graph that displays data in the form of coordinates. The coordinates are those points. Okay, in this case, they've indicated different shapes just to indicate that this one is for this line and the triangular one is for the other. So we've got the rectangular point, and there we've got the triangular point. It's just to indicate that this point or these points belong to this graph and the other points belong to the other graph. Okay, and then of course a pie chart. Okay, this is how a pie chart looks like. It is a circular graphical representation of relative, like remember I said, circular graphical representation of relative portions of data in the form of slices. So I'm sure when you look at the picture, you can actually have an idea of how a pie chart looks like, or how can you define pie chart using your own words. Okay, box and whisker. Of course, you must have a picture of box and whisker now. If you look at this one, it is indicated that there's a minimum, there's quartile 1, there's median. Okay, in some cases they say it's quartile 2, we've got quartile 3, and we also have maximum. And remember, between minimum and quartile 1 we've got 25%. Between quartile 1 and median we also have 25%. Between quartile 2 and upper quartile we've got 25%. Between quartile 3 and maximum we also have 25%. So if you interpret this, you can say between minimum and median we've got 25 plus 25, which is 50%. Between quartile 2 or between median and maximum we've got 25 plus 25, which is 75%. Between quartile 1 and maximum we've got 25 plus 25 plus 25, which is 75, so 75%. So in this case as well, the examiner might ask you to give the percentage between maybe a minimum and quartile 3. What is the percentage between minimum and quartile 3? And you know that we've got 325%, which is 75%. So please, it's very, very important to have a picture of any box and whisker diagram or any box and whisker plot. Of course, scatter plot, very, very important. Now the scatter plot, remember in this case, normally when they give you the points and then they say plot them, okay, you will take the points and plot them and join them by means of straight line. So in this case, you can see the points cannot actually be joined, because we say the points are scattered, or the points are all over the place in such a way that it's very difficult to connect them by means of a line, by means of a straight line. The points are scattered. But you can see that even if they are scattered, you can see that in terms of a direction, they can give you an idea of in which direction they are moving. So in this case, you can see they are moving in that direction, and we've got a negative correlation. In this case, they are sort of moving in a negative direction, and in this one we say there's no correlation. So if there's no correlation, you can't tell if they're going up or they're going down. You can't tell if they're going up, they are going down. Now, what do we mean by a positive correlation? If you look at this one, we say it's a positive correlation. I can just give you an example, boys and girls. Let's say, for instance, during summer, when it's hot, okay, or when temperature increases, when the temperatures increase, the sailing of maybe ice blocks and so on, okay, the sale of ice blocks is very fast. So in other words, for this one we'll say as temperatures increase, the sale of ice blocks will also increase. So that will be a positive correlation. When you compare the two of them, when a temperature increases, the sale of ice blocks also increase. So that one we say it's a positive correlation. Okay, now with a negative correlation, an example of a negative correlation, it's in a situation where when one item increases, the other one decreases. Okay, like for instance, in this case, if we say the negative correlation, okay, when one item increases, the other one will decrease. When one item increases, the other one will decrease. Let's say, for instance, during summer, in most cases, we know the sale of coffee, for instance, if the temperature increases, or the temperature increases, then the sale of coffee will decrease, because people would not actually prefer to buy coffee when it's hot. Most people, they will not prefer to buy coffee. So in this case, we say when temperature increases, the sale of coffee decreases. So that will be a negative correlation, because when one item increases, the other one decreases. And in a case where there's no correlation, what do you mean there's no correlation in this case? Like, for instance, I can say with the performance of maths lit in the classroom. Okay, if I want to identify the learners who are performing, or if I want to check the performance of the subject in a classroom, I can say, can I say the shoe sizes of learners against their performance, the shoe sizes of learners against the performance of the subject. So you can see that in that case, there will never be a correlation. It does not necessarily mean a learner who is wearing a smaller size will automatically perform bad in the subject, or a learner who's wearing a bigger size will automatically perform better in the subject. So in these two, I cannot actually relate the two. I can't even relate the two, because I, I can't assume that, or I can't tell that a learner who's got a bigger size, like I indicated, will automatically perform better in the subject. So I can't relate the two. So in that case, we'll say there's no correlation at all. I can't compare the subject performance against the shoe size. There's no correlation at all. So that will be no correlation in a case where the points are scattered or are all over the place in such a way that I can't tell whether they are increasing or decreasing. Okay, now we're just going to take you back to the exam type questions, the type of questions that you must expect. But remember the types of graphs that you might encounter in the examination. Very, very important. Sorry. Now, this was taken from Mpumalanga September. It's supposed to be 2022, but it's fine. The question why it was question one. And it's the pie chart below shows the major avocado producing countries in the world. Avocado has increasingly found attention or a growing share in the international markets. Use the graph and the information alongside to answer the questions that follow. So there you've got the information, and then the information is also displayed on the pie chart. 1.1, identify the country that produces the third most avocados in the world. Identify the country that produces the third most avocados in the world. Now, in this case, in order to identify that, we must have the first most, which will be the highest, and we must have the second most, and then of course the third most. So they want to know the third country, okay, the third most avocados in the world. Now, if I look at this one, the highest one, the first one is Mexico. So it's Mexico, okay, because Mexico has got 34%. And then the second one, it's, if I check here, I've got 11, I've got 8, I've got 6, I've got 5, 4, 3, 2, and then I've got 2, and then I've got other countries, okay? All right, so in this case, so I have to check. So if you look at this one, it's other countries are producing 23%. Other countries are producing 23%. So in this case, they say identify the country. So the first one will be Mexico. The second one will be Dominican Republic. Okay, and then the third one. Okay, no, actually, in this case, boys and girls, it is Mexico, and then according to the pie, other countries that are not mentioned combined are the second most. So this one must be the other countries. Okay, other countries combined. Other countries combined will be the second most, and the third most will be Dominican. Dominican Republic. the Dominican Republic will be the third most. Okay, so because we've got 34, the second one is other countries combined, and then we've got the Dominican Republic with 11%. So the third most will be Dominican Republic. Okay, then the next one is South Africa also produces avocados. Explain where in the above graph each share will be found and explain why and why. Okay, South Africa also produces avocados. Explain where in the above country. Now, if you look at the pie chart, there's no way South Africa is mentioned. So obviously South Africa will fall under other countries. So that will be under other countries, but it does not necessarily mean South Africa produces 23%. South Africa with other countries that are not mentioned here, all of them produces a certain percentage. Now you can see from the mention, the smallest percentage that is indicated is 2%. Okay, so that is USA. So all the other countries that are mentioned, all of them combined, they produce less than 2%. Okay, explain where in the above graph its share will be found and why. It will be in other countries because it produces less than 2%. It produces less than 2%. So the reason is, okay, explain where in the above graph, that will be in other countries, and then because it produces less than 2%. Okay, and then 1.3, they say a statistician states that the Dominican Republic, Indonesia, and Kenya produces 1/5 of the global share of avocados. Show by means of calculations whether he is correct. A statistician states that the Dominican Republic, Indonesia, and Kenya produce 1/5 of the global share of avocados. Show by means of calculations whether is correct. Now let's check the percentages of the three countries combined. The percentages of the three countries combined. Dominican, it's 11%. So it's 11% plus the next one is Indonesia. Let us look at Indonesia. Indonesia is 6%. So it's 6%. And then the next one is Kenya. So if we say Kenya, then we get plus Kenya, which is 3%. So the total percentage for the three countries, it's 11 plus 6 plus 3, which will give us 11 plus 6 is 17, then is, and then this will be 17 and is 20%. So all of them combined, all the three countries combined will give us 20%. Now let's check. 20% is the same as 20 over 100. Okay, 20% is the same as 1 over 100. 1/5, 1/5 means 1 over 5. Now how do we check if 20% is 1/5? We say 20%, 20%, a percent means over 100. Then we say 20 over 100. Then now we divide 20 into itself once, into 100 5 times. So therefore this one will give us 1 over 5. Okay, so from this one they say show by means of calculation whether he is correct. Then we can say in this case he is correct. He is correct because the three countries combined, they give us 20%. And when we convert the 20% to a fraction, we get 1 over 5 in simplified form. First is 20% is the same as 20 over 100, and 20 over 100 is the same as 1 over 5. Can you see how easy these questions are, boys and girls? These are very, very easy questions that are based on the graphs. Then the next type of question, this one was taken from the Exemplar 2014 paper 1. It's Jan also studied the population distribution percentages according to the age groups. The pie chart alongside shows the distribution percentage of the South African population according to age groups. The pie chart and the accompanying bar of the pie chart above indicate, it must be alongside, the age group and the percentage of people in that age group in South Africa in 2012. use the graph to answer the questions that follow. Okay. Now, the first question is label the sector marked R on the pie chart. Now, the R, what does R represent? Okay, you can see that this part represents 0 to 14, this one represents 15 to 24, and this one represents 25 to 54, and in this case, this one represents 55 to 64, and also 65 plus. So if we just summarize that one, we can say this one represents 55 plus. So it's 55 plus. So it's all the people above the age of, or from 55 and above. It's for 55 and above. So R represents 55 to 64 and also 65 plus. So in simple terms, it represents 55 plus. Okay, then the question is for this one, 2.2, calculate the percentage of people in South Africa aged 25 to 54. Calculate the percentage of people in South Africa aged 25 to 54. Okay, so of age in 2012. Sorry, in 2012. Right. Then if you look at this is 28.4%, 21.0%, and in this one, the total, if we add this one, will give us 6.8% plus 5.9. So 6.8 plus 5.9. So this gives me 12.7. So all these two combined, they give me 12.7%. Okay. So what which one is the remaining sector? I've got this one, I've got this, I've got this one. I don't know this one, and this is the one that I have to calculate. But I know that the total of R is 12.7. So therefore, in order to find 25 to 54, I'm going to say 100%. Then I subtract the percentages that I know. First thing, I know 12.7, which is the one that I've just calculated. And then I also subtract 28.4, which is for 0 to 14. Then I also subtract 15.4. No, sorry, it's 21. Okay, I said 28.4. This one must be 21.0. So this must be 21.0%. 21.0. So it's 12.7, 28.4, and then 21.0. So this will give me 100 minus 12.7 minus 28.4 minus 21.0. And then this is 37.9. Okay, then 37.9. So that is the answer for the age 25 to 54. So it means then in 2012, 25 to 54 years, 25 to 54 years, they only made about 37.9% of the South African population. Okay, and then this one is, in which age group did the majority of the people in South Africa fall in 2012? In which age group? So the age group, it's, remember this one we said it's 12.7. So this one we said is 12.7. So the majority of the people were in the one that we have just calculated, 37.9. So 37.9. So that was 25 to 54. 25 to 54 years. Okay, the one that we have just calculated, that is where the majority of the people fell in 2012. Okay, then the next one is, in which age group is the median age of people in South Africa likely to fall? In which age is the median age Okay, in which age group is the median age of people likely, or in South Africa, likely to fall? So the median will be between 25 and 54, 25 to 54. So the median, which is the middle, is 25 to 54. Also 25 to 54. Okay, then the next question, still on the very same one. They say in 2012, the growth rate of the South African population was negative 0.412%. Okay, negative 0.412%. Determine the population of South Africa in 2011 if the population was 48,810,427. Okay, now we know that usually in an examination, they will give you a percentage increase. Now this one, percentage growth is simply means increase. Okay, we expect that to increase. So if they say percentage increase, then this is the formula that is given. Normally they will give you these three values, and then you just substitute and work out the answer. Okay, but what is happening in this formula is we are given the value of the percentage increase or the percentage decrease or percentage growth. We are given the value of population in 2012. Now we have to calculate population in 2011. Okay, now when we do the substitution, we're going to do the substitution like this. What I'm going to do, boys and girls, I'm going to do the substitution. The population for 2012, it's 48,000. Sorry, and not 48,000, that is 48,810,427. Sorry, 48,810,427. Okay, and then I minus, I don't know the population in 2011, so I'm just going to leave it as P. Then we say over, right? Okay, over the population in 2011. So the population in 2011, I also don't know it. So I'm just going to leave it as population. Then this is times 100%. Okay, if I knew the value of P, I was going to say 48,810,427 minus the value of P divided by the value of P multiplied by 100%. The answer that I was going to get was going to be negative 0.412%. Okay, negative, I hope you can see it. Okay, it's negative 0.412, negative 0.412%. Okay, now I need to simplify this. Okay, if I simplify this one, then I'll get 48. Okay, 48,810,427 minus P. Okay, let me just rewrite this over P multiplied by 100%, and then this is the same as negative 0.412%. So now I need to cross multiply. Okay, so now if I cross multiply, this is going to be P, I'm going to multiply it with 0.412%. So it's negative 0.412%. Then it's P. It's equals to, I still have, now remember this one, we're supposed to multiply. We're supposed to multiply. So this will give me, remember 100% is the same as 100 over 100. So this will give me 48,810 and then this will give me minus P. Okay, then now I need to take the P to the left hand side. So this will give me negative. So now I can change the 0.412 and then I say 0.412, then I divide it by 100. Okay, so this will give me a negative 0.0412 P. Then I take P to the left hand side and say plus P, and then this is equals to 48,810,000. I forgot to indicate 427, so this must be 427. Okay, 427. Okay, then from this one I need to add the two values. So I've got negative 0. I've got negative 0. Let me see, I think 0.412 divided by 100. This must be 0.0. Must be two zeros there after the comma. So I get negative 0.00412, and then I say plus 1. Then I get, because if I add these two, which are the which must be added, I get negative 0. No, I get positive. I don't get 0. I get 0.99588. Then is P equals to 48,810,427. Okay. I don't have a space there. I'm just going to write it here. So I've got 0.99588 P. It's equals to 48,810,427. Okay, then now I need to divide 0.99588, and then on this side I also divide by 0.99588. Then this and this one will cancel out. Then if I take 48,810,427, I divide it by 0.99588. Okay, and then I get, okay, 1 2 3 4 5 6 7, I get 49 million. So the answer there for dividing this one, I'm just going to get a better space to write the answer there. I'm getting 49, then I'm getting 012, and then I'm getting, okay, I'm getting 49012, I'm getting 35, okay, 79. Okay, so I get 1 2 3 4 5 6. So this must be 4901. So the answer there, it's 49 million. 49 million. 49,012,357. So this must be 357,91. Okay, so I've got 48,810,000 divided by 0,9958, and then I get 12,357. Okay, so this is the answer that I get for number 2.5. Okay, so it's a very long one. It's a very long one. So so when usually they give you the values of the population in 12 and the population in 2011, and then you do the substitution. But in this case, the percentage is given, so we just need to substitute and then calculate the percentage increase or the percentage decrease. Okay, so that was number 2.5. Then when we move on to question 3, it's the graph below indicate, or the graph alongside indicate the safety level of people in their residential area during the day. Use the information above to answer the questions that follow. Then I've got 3.1, name the type of graph drawn alongside. Okay, we indicated the types of graphs at the beginning, boys and girls. Now the type of graph in this case, it's a bar graph, but it's not just any bar graph. In this case, it's a compound bar graph, or you can say multiple bar graph. Okay, compound bar graph or multiple bar graph. Okay, then this is the answer for question 3.1. Then for 3.2, they say determine the increase in the percentage of people who felt fairly safe between 2019 and 2022. Determine the percentage increase in the percentage of people who felt fairly safe between 2019 and 2022. Now, if you look at our graph, which one represents which one indicates 2019? So the black one there, okay, the one that is colored in black represents 2019. And then the 2021 is this one, okay? And then the 2021 is this one, okay? And then the 2022 is this one. So you can see the one that is colored in black and the one that is dyed, okay? The white dyed, and the one that has got a combination of black and white dyed, and the one that is not colored in, okay? It's not colored in, it represents 2022. Now from 2019 to 2022, it means need to indicate. But which one really indicates fairly safe? Okay, which one represents fairly safe? So in this case, we're going to look at this for fairly safe. The 2019, it means it's this one. And then the 2022, it means it's this one, the one that is not colored in. The one that is colored in black, and the one that is not colored in. The one that is colored in black is for 2019, and the one that is not colored in, it's 2022. Right, so now we need to indicate the percentage increase from 33.1 to 37.2. From 33.1 to 37.2, so this one we just say 37.2 multiplied by 33.1. Remember, these are in percentages. 37.2 minus 33.1. So when we use a calculator, is 37.2 minus 33.1. Okay, so we get I get 4.1%. So it's 4.1%. So the increase was from 33.1 to 37.2. That was an increase by 4.1%. Okay, then the next question, still based on the very same graphs, it's the number of people who felt unsafe when walking in a residential area during the day in 2020 was 2.85 million. The number of people who felt unsafe when walking in a residential area during the day in 2020 was 2.85 million. Now, 2.85 million is the same as 2,850,000. Okay. Now, determine the number of people to the nearest 100,000 in South Africa in 2020. Right, we know that the number is 2,850,000 for the people who felt unsafe. Okay, but what percentage was this? Do we know the percentage? What percentage was this? So this, it's a certain percentage of the whole country. It's a certain percentage of the whole country. Now, if I go back to my graphs, then I look at my graphs and say this ones represents very safe. This ones represents fairly safe. These ones represent a bit safe, and this one represents unsafe. But if I look at the percentages, this one indicates 5,6. This one indicates, this one the percentage is not indicated. This one indicates 6.1. This one represents 6.5. But now, for unsafe in 2020, obviously it must be this one. But is the percentage not given? The percentage is not indicated on the bar. But now I can actually estimate it. Okay, I can estimate it, because if you look at this one, it's not given. So obviously I'll have to estimate that percentage. Now, if I look at this one, it's between 0 and 10. Between 0 and 10, I know that it's 5. Okay, between 0 and 10, it's 5. But this one is 5.6. And this one, it's a little bit below 5.6. Okay, it's a little bit below 5.6. So it can be very difficult to read it there, what exactly the percentage is. So, but obviously I have to estimate. If I have to estimate it, it can't be 5.6 because it's below. It can't be 6.1 because it must be below. It can't be 6.5 because it has to be below, because this one is a little bit lower. So what I'm going to do in this case is I have to estimate this one. To estimate it, I can say it is just below 5%. Anything below 5, just below 5%. So I can estimate it, to be, let's say, 4.9%. Okay, 4.9 or about 4.8. Okay, because it is just shorter than the one of 5.6. So from this one, I know that this is 4.9%. Okay, so how do I calculate it? I know that if I have to calculate 4.9% of SA, it must give me 2,850,000. Okay, if I have to calculate 4.9% of South Africa, it must be 2,850,000. Now I need to calculate this. What is the population of South Africa? Okay, now if I say 4.9, I say 4.9 over 100 of South Africa. This will give me 2,850,000. Okay, so let me take it a little bit to that side so that it can be clear. Now I need to cross multiply. If I want to cross multiply, if I want to remove this, I will multiply by 100 over 4.9, and then I'll also multiply by 100 over 4.9 on the other side. So this and this will cancel out, this one and that one will cancel out, and then I get South Africa, it's equals to, okay, 1 million. So I take 1,280,000. So it must be 285,000. So 285,000. So this must be 285,000. 285,000, not 280,000. 285,000. 285,000. I multiply by 100, and then I divide it by 4.9. Okay, so this one, when I calculate it, I've got 1. Okay, let me check. So it's 1,285,000. Okay, so it's one. No, sorry, I made a mistake. It must be 2 million. 2,850,000. Sorry, boys and girls. 2,850,000. So if I take 2,850, 2,850,000, and then I multiply it by 100. Then from there I divide it by 4.9. Okay, so I get 58. Okay, 163, and then 265. 265 31. This must be the number of people. So in the end, it must be 58,163,265. Okay, this is the answer that I'm getting from my calculator. Sorry, not 58,000, 58,163,265. But now the question was, I must round it up to the nearest 100,000. Okay, so if I round it off to the nearest 100,000, so this will be, if I've got 163,000. Okay, so for this 163,000, if I have to round it off to the nearest 100,000, okay, it's going to be 160,000. So it's 160,000. Okay. Okay, so if I've got 58,163,265, now I need to round it off to the nearest 100,000. Okay, so if I've got this 163, so 163 obviously is between 100 and 200,000, isn't it? It's between 100 and 200,000. Now, if it's between 100 and 200,000, is it more close to 200 or more close to 100? So this will be about 58,000. I'm just going to write it here, 200,000. Okay, 58,200,000. 58,200,000. That is how I round it up to the nearest 100,000. Okay, then number 3.4, it's the percentage range for the people who felt very safe is 7.7%, and the lowest is 44.1. The percentage range, now the most important word is the range. Okay, the percentage range, the most important word there is range. We know that a range means if I take the highest value minus the lowest, then this will give me the range. Okay, the highest minus the lowest, then that will give me the range. Now, which one is the highest? Okay, the percentage range for people who felt very safe is 7.7%, and the lowest percentage is, so it means 7.7 is the value of the range. So it's 7.7%. And then the lowest, so it means if I take the highest, I minus the lowest, is 44.1. 44.1%. If I take the highest, I subtract the lowest, I get 7.7%. I know that we are used to a case where we have to calculate the range and then the highest value and the lowest value are given. But now in this case, it's different. You are given the highest, you are given the lowest, and you are given the range. You have to calculate the highest. So this is how we substitute. Now, if we're looking for the highest value, then we say therefore the highest value, it's equals to 7.7% plus 44.1%. So I just take 44.1% to the other side, 44.1 to the other side. Then now I can add 7.7 plus 44.1. Okay, 7.7 plus 44.1, then I get 51.8. So it's 51.8%. Okay, so this is how I get the highest value. So just remember that even from that formula of the range, they can still give you the range, they can give you the highest value, and they ask you to calculate the lowest value. Okay, or like in this case where they give you the range, they give you the lowest value, and they ask you to find the highest value. Very, very important. You must go and practice that, boys and girls. Okay. Now the next question. It's the national and provincial budget process. It's a continuous cycle that runs from April to March the following year. The medium-term gross tax revenue outlook in billions for the South African government is indicated in the graph alongside. Use the graph to answer the questions that follow. Then 4.1, is the data displayed on the graph discrete or continuous? Okay, now is the data displayed on the graph discrete or continuous? Now we know that most of you are actually struggling to interpret the two with discrete and continuous. I know that most of you tend to think that if the values are given in, or if the values are given as whole numbers, if values are given as whole numbers, it means they represent a discrete data. And if values are given in decimals, then they represent continuous data. But now you need to be careful. In this case, we are talking about the nature of the values. How do we get the data? Do we get the data by, because like for instance, I can do measurement. Okay, I can do measurement and then I get whole numbers. Okay, I get whole numbers. Then you can't say the values that I get after measuring, because they are whole numbers, therefore they are discrete data. Okay, like for instance, the value of money. How do we get the value of money? Okay, how do we get the value of money? The value of money, we need to count it. Okay, so it means it's a discrete data. Discrete data is the type of data that you get by counting. And then a continuous data is the type of data that you get by measuring. If I measure something, I can still get a whole number. Okay, if I measure something, I can still get a whole number. But when I get a whole number, it does not mean that will be a discrete. So in this case, the data that is indicated here, if you look at 1563,8, we've got 1547,1, we've got 169,2. Okay, can you see that these values have got commas? But these values, they represent money. They represent the value of money. How do we get the value of money? We get the value of money by counting. Okay, we get the value of money by counting. Nevertheless, they say these values are in billions. If you look at how they are indicated, like for instance, we've got 1563,8. If I take this one as an example, it's 1563,8, but this is billion. Okay, so if I want to write it as an ordinary number, okay, I will say 1563,8, and then I multiply by 1 with 9 zeros. I want to write it as an ordinary number. So in the end, if I take 1563,8, I multiply by 1 with 9 zeros. Okay, and then I'll get 1563, then I get 8, 00, then I get, okay, so what is happening in this case is now the value of money, you can see that is still 1,563,000,000. Okay, so this one, let's see, it's actually a trillion. Okay, so because I've got, it's actually 1,563 billion, 1,563 billion. Okay, and then it's 800 million. Okay, or one can say it's 1 trillion, 563 billion 800 million. Okay, so however way that you can read this, if I take this Then now I want to write it as an ordinary number. Okay, it's just the same if I say this is 1.5 million. Okay, if I say this is 1.5 million, I want to write it as an ordinary number. I just take 1.5, I multiply by 1 with 3 zeros. With 6 zeros. And this will give me 1,500,000. Okay, or 1,500,000. If I take 1563, according to the information, whatever I see there, it's actually in billions. But when I see 1563,8, it's 1,563,8 billion. 1,563,8 billion. If I want to write it as an ordinary number, I take this value, I multiply it by a billion, I multiply it by 1 with 9 zeros. Then this is what I get. If I look at this number, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it means until here, this is a billion. But how many billions do I have? I've got 1,563 billions. Then it's 800 million. But if I count the number of digits, I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got trillion. So how many trillions do I have? I've got 1 trillion, and then I've got 563 billion, 800 million. Okay, so you must go and practice those big numbers. But going back to our question where it says, is the data displayed on the graph discrete or continuous? At the beginning, when you look at these values, you can see that these values have got commas. But these values, they represent the value of money. How do we get the value of money? We get the value of money by counting. So that will be a discrete. It's a discrete data. It's not about how the number looks like, but it's about the nature of the number. It's not about how the data looks like. It's not about the data having a decimal, but how do we get that data? Do we get the data by measuring, or do we get the data by counting? I usually give an example, like for instance, let's talk about the height of learners. Okay, in a class you may get learners with 100 or 1 comma, let's say 1,5 meters, or we've got 1,6 meters, or we've got 1,7 meters, or we've got a learner who is very tall, 1,8 meters in the classroom. If you look at these values, okay, if you look at these values are in decimal form. How do I get these values? Obviously, I have to measure the learners. Okay, I have to measure the height of the learners. So this will represent what? This will represent continuous data. But let's say somebody decides to measure the height of the learners in centimeters. So in centimeters, it simply means this will be 150 centimeters, 160 centimeters, 170 centimeters, and 180 centimeters. Okay, but if you compare these values, okay, if they have to ask you whether this is discrete or continuous, but now if you're going to say because these are whole numbers, and then because they are whole numbers, they will be discrete. No, that will be wrong. But in this case, it's how do we get that information? Do we get the information by counting or by measuring? Okay, if you want to know the number of tables in your classroom, you'll have to count them. Okay, if you need to know the number of tables in your classroom, you'll have to count them. If you want to know the length of each and every classroom in your school, you'll have to measure them. You'll have to measure. But it is possible that when you measure the length of the classroom, you can get a whole number. Now, when you get a whole number, does that mean that is a discrete? No, that will be a continuous because you got the information by measuring. If you count the number of tables, yes, of course, when you count, you'll never get a decimal. But obviously, counting means a discrete. So we need to be sure about the difference between discrete and continuous. Okay, the discrete is the type of data that you get by counting, and the continuous data is the type of data that you get by measuring. It is not about how a data looks like. Okay, I hope that is very clear, boys and girls. Okay, then 4.2 they say write the amount of budget outlook 2023 of 2022-2023 in full digit number. Budget outlook, now budget outlook is the one that is colored in gray. Okay, then we must go to for 2023. Okay, so 2023, so obviously it's this one. Okay, so we've got 2021 and 2022. So 2022-2023 is this one. Okay, then 2022-2023 we have to take the budget 2023. The budget 2023 is the one that is colored in gray. So I have to check this. 2022-2023 is this one, and the budget outlook 2023 obviously is this one. So this number is 1692.2. Okay, so it's 1692.2, but remember this is in billions. Okay, this is in billions. 1692.2 billions. They say write it in full digits. You can see that I've already done it, similar to the example that I was giving the previous. So if I want to write it as an ordinary, I will say 1692.2, then I multiply it by 1 with 9 zeros. 9 zeros. Okay, then this will be 1692, then it's 200, and then now it's going to be 6 zeros. Okay, so I take 1692.2, I multiply by 1 with 9 zeros. Okay, then this will give me, if you read it, it's 1, 2, 3, and then 200. Okay, so I get 1,692 billion 200 million. Okay, right? So boys and girls, that is number 4.2. Okay, so that is how you do it. And then I think we have been talking, or I've been talking for a very long time now. I just want to take 1 minute break and then I'll come back now.
Excellence. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinanga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
All right, welcome back, boys and girls. I hope you are enjoying the lesson. I was advised that while I was busy presenting number 4.2, it was not actually visible on your screen. So I'm going to take you back to number 4.2. So for number 4.2, it's the question was write the amount for budget outlook 2023 of 2022-2023 in full digits. Okay, now if you can look at the procedure, it's almost the same as what I was explaining at number 4.1, where I was trying to indicate that even though the values are indicated in decimal form, but if we convert them to ordinary number, you will see that they are not actually in decimal form. But however, I was trying to indicate that it does not mean if a number is in decimal form, okay, and then it means that is a continuous. Okay, it depends on the nature of the data. How do you get that information? If I say you've got 1.5 million, okay, if I convert it to an ordinary number, it's 1,500,000. So 1.5 million rands is the value of money. How do I get the value of money? Then you get the value of money by counting. Okay, so at number 4.2, when we had to write the amount for the budget, so I had to look at 2022 2023. So there is 2022 2023, 2022 2023, and then after finding 2022 2023, I had to look for the budget outlook. Now the budget outlook in this case is the bar that is colored in gray, the one that is colored in gray. Then I found that they have indicated 1692,2. Then I said 1692,2, and then I have to indicate that this is actually in billions. Then how do I convert this to full digits without the word billion? I take 1692,2, I multiply by 1 billion. So in other words, I multiply by 1 with 9 zeros. I multiply by 1 with 9 zeros. Then from this one, I get 1692,2, then is 00, 000, 000. When I read this, it depends on where I start. If I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's 9 digits, so it means it's billions. But how many billions do I have? I've got 1,692 billions, and then it's 200 million. Okay, 1,692 billions, and then 200 million. Or one can say I've got 1,692 billions, 200 millions. Okay, but the examiner was actually looking for an answer, or was looking for you to write the value as an ordinary number without the word billion. Okay, then number 4.3, it's calculate the difference between the maximum amount for budget outlook 2023 and the minimum amount for budget outlook 2022. Calculate the difference between the maximum amount for budget outlook 2023 and the minimum amount for budget outlook 2022. Okay, now the highest amount, which is the maximum for budget outlook 2023. Okay, now for budget outlook 2023, it means I must look at the graph that is colored in gray. So the highest in this case is 2043, 2043, 2043, okay, 2043. Budget outlook 2023 is the gray one. Okay, so the budget outlook for 2023, the maximum amount. Okay, so 2043, and then the difference, I must take the minimum amount for budget outlook 2022. So the budget outlook 2022, it's, in this case, it's 15. Okay, so the budget outlook 2023, boys and girls, in this case, calculate the difference between the maximum amount for budget outlook 2023. Budget outlook 2023, is this one. Okay, budget outlook 2023, it must be 1787. Okay, 1787 1787.5, and the minimum budget outlook for 2022. So the minimum, it's 15. Okay, so 1598.4. Okay, so so in this case, it's 1787.5 minus 1598.4. So if I calculate the difference, I get 1787.5 minus 1598.4. And then I get 189.1. Okay, but remember these values are actually in billions, so we need to indicate 189.1 billions. 189.1 billions. So this is how we calculate the difference. Okay, so that is the answer for number 4.3. Okay, now boys and girls, I can see that time it's not on my side. I wanted to continue with the next question. So unfortunately, time is not on our side. So this will bring us to the end of today's lesson. Thank you very much for watching this lesson. I hope to see you next time. Goodbye.